Hello everyone, welcome back to the new video. In this video, I will go over some of the functions that are important when we are working with the data frames. So I have already imported the libraries pandas and numpy, and then I have some of the sample data. I have some of the sample lists that I am going to use here. So the first function is the zip function. What zip function does is it combines the item of the first, you can say, iterable with the first item of the second iterable. So suppose we are passing like two iterables inside the zip function, it will combines the elements according to their position. First element with the first element of the second element of the first list with the second element of the second list. And the syntax for zip function is like zip iterable 1 comma iterable 2 comma iterable 3. So that's how we're going to use the zip function. And after using the zip function, the output is going to be the zip object. For example, let me use the first list that I have here, name, age and movie. Here suppose in the zip function I am passing name comma age comma movie, and I want to print out the data, and also I want to print out the type of data. Let's see what the output is. So here we can see the output is showing that it's a zip object at this particular location, and then the type is zip type. So here it's a class zip type. And if I want to see it, like how it's working, if I do like print list of data, if I do like this, then here it will print me the list. How it's printing me the list? I am passing name, age and movie, and here it's Megan 25 transformers. If I check it in my lists, it's like Megan 25 transformers. Second one is going to be Selma 30 Desperado. Selma 30 Desperado, yeah. So that's how zip function works, and we can have as many iterables inside the zip functions as we want. So here suppose in one of the list I have, suppose here I have like 42 50 30. This list has more elements than the other two lists. If I execute it again and if I run it here, let's see what the output is going to be. Here again the output is only until Scarlet 32 Avengers. That means Scarlet 32 add Avengers. Why? Because zip function will only go up to the shortest iterable that we have, and here the shortest iterables are name and movie that have only 4 elements each. So that's why it's going on to 4. So suppose in here I will do like Megan again, and here I will do like Transformers 2. Let me run this, and here let me run this here. So now it has one more element, Megan 42 transformers, because now this is the shortest list. So that's how the zip function work. Let me delete these first to show you more examples how we can use the zip function. So suppose I want to create a data frame from multiple lists I have. So what I can do, I can just create a zip function like this, and then I want them in the list. What I can do, df is equal to pd dot data frame. In the data frame, first is the data. What is data? Data is data, and then I want the columns. What are the columns? Name, age and movie. And here if I do df, so here I can get a data frame from multiple lists. So I can use zip function to create a data frame from multiple lists. So suppose now I have this data frame and I want to iterate over it. I can use zip function again here. So what I can do is like for a comma b in zip of df of name comma df of let's say movie, I want here f of like name has worked in B. It's not name here, it's A here. That's what I got. So let me run this. I can see here like Megan has worked in transformers. So this is the, I am looping over these two columns, and so I can let like Megan has worked in transformers, Salma has worked in Desperado. So now suppose I want to use the third element also, like C. What is going to be the C? C is going to be the df of age, and here I want to do like and is C years old. So let me run this. Now I can get all the three here, like Megan has worked in transformers and is 25 years old. That's how we can use zip over the data frames. And suppose one more thing here, like I can create the dictionary here. I want to create a dictionary here. So let me do like my dict is equal to this, and for name comma movie in zip of df of name comma df of movie. What I wanna do, I wanna append it in my dictionary. My dict of what I wanna say, name is equal to movie, and here I want to print my underscore dict. Let's see here. If I printing my dictionary here, we can see it's Megan Transformers 2, Selma Desperado, Cameron Diaz Charlie's Angels, and Scarlet is Avengers. But here we can see in the data frame, for Megan I have Transformers, for Megan I have Transformers 2, but here it got only one. Why? Because we know that dictionary key cannot be repeated. Key have to be different. It has to be unique. So it cannot be here one more Megan with Transformers. So in that case, what I can do here, let me just copy this part and this part here. I will check if name in my underscore dict, then what will I do? I will do my underscore dict of name dot append. What will I append? I will append the movie. Else what I want my underscore dict of name is equal to, I want list here movie, and here now I wanna print my underscore dict. So here I got the list here of the movies that are done by Megan. So here Transformers and Desperado, Transformers 2. For Salma it's only one movie, Desperado. So that's how we can use zip function. Like I guess I explained more than what was relevant for the zip function. So these are some of the use cases that we can use zip function. Next function is the enumerate function. What does enumerate function does? It used to, if we want to iterate over the iterables like list and tuple, and while iterating we want both the index and the corresponding element to that index. So that's where we can use the enumerate. So I have this list again here. Instead of Megan, let's do Megan Fox, something like that, and I want both the index and the element for it. So then what I can do, like for I want like index comma element in enumerate of name, I want to print out, let's do the f string here, index value is element. We can see like 0 value is Megan, 1 value is Selma, two values Cameroon Diaz, something like that. That's how we can use the enumerate on the list. So suppose I have this particular list. Let me create new list. New underscore list is equal to 2 3 4 5 comma 6, and on this list I want to apply like double. I want to double each element. There are easier way to do it, but I will just explain it using the enumerate. Oh, not on that actually. Let me get the this data frame. Let me use the df only. Here I want to double the age here. So what I can do here, double underscore age, and in this I will pause the list here. Let me try here. Oops, if it's going to work or not. Here what I can do, for index comma age in enumerate of what x, I will do here, it's going to be the list x of index is equal to age. I wanna double it instead 2, and then I will return x. So suppose I want to call double underscore age on df of age. Let's see here. So here we can see it doubles the age, 50, 60, 70, 64, 84. So now these are double the ages of what they have here, and I can create a column of it by calling this function and using the apply method, but I have not explained the apply right now, so I will just keep it here right now. Whenever apply method is going to become, I will explain it. So that's how we can use the enumerate function. So third function is the isInstance function. What does isInstance function check? It check whatever object we are passing within the function. It will check if that particular object is the instance of the subclass or the tuple of the subclasses. And the syntax is here that I have explained, isInstance, and then within this first argument is going to be the object that we want to check, and then after comma we are going to have the single argument, either the subclass that we want to check, or we can have the tuple of the subclasses within which we want to check. So here I have x is equal to 10, and I want to check if this is an instance of an integer or not. What I can do is, if isInstance, what I want to check, x is instance of integer, then print f x is integer, else print, and then here again f strings x is not integer. So here I want to check if x is a subclass, or you can say part of this int. Let me check. Here it is an integer, 10 is an integer. So suppose if it's like 10.5, let's check it here. 10.5 is not an integer because it's a float. So suppose I want to check if it's an integer or float. There is some requirement that in my column I have to do some operations, and I want to check if they are integer or float, so I can have this kind of criteria there. And here I can check, oh, it's a float also, so I will do something like this. Yeah, so 10.5 is a integer or float. So suppose instead of this I can do like hello, and I want to check this thing. Here it's a string, we know that, so we can check like, yeah, hello is not integer. That's how we can check it. So I have this one more example here in which I have one of the, you can say, age here, it's not numeric, it's like 25, and I want to suppose like filter it down. So what I can do here, I can do like numeric underscore age is equal to df of df of age, and here on this I want to do like dot apply lambda of x, and here is instance x. I want to check if it's an integer or float, something like that. And then here I can check the numeric age. Let's see here. Yeah, so here I am filtering on the data frame value age, and on that I am applying a lambda function. What is lambda function? It's an anonymous function that has no name. What is this function doing? In this function it will checking if x is an instance of integer or a float. If it's an instance of an integer and a float, then apply that function on this age and just return me those values. So here it's filtering it. So here you can see the last value was 25 for transformers 2, and Megan, it's not here because it's filtered it down for those values. Yeah, so this example is also the same, so let me delete it. Yeah, one more example. In this example I have 10, 20 and some string, and this 40, and I want to check if it's a alpha numeric, if in this particular list there is an alpha character there or not, and if it's there I want it in the uppercase or something like that. So what I can do is here for element in L, I will loop over this, and then I will put the criteria like if is instance. What I want to check? I want to check for the element. If element is an instance of string, if it's an instance of string, and element dot is alpha. So this is a functional, this is one of the function that we have to check if it's an alpha. Then what I want to do, I want to do like element is equal to element dot upper, and then I want it in my another list that I will do here. And then what I want to do, L1 dot append, just append the element in that list. And let me get my list. Here there is only one character that is part of string, and also it's an alpha, and then it is converting it to the uppercase. Suppose I have this is string, and I will make it also a string. So this is also a string, this is also a string, so both are satisfying the first criteria. And then second criteria is alpha. Is just alpha? No, it's not alpha, so it still convert this part only. Let me this, and here it will just return me this because still it's only satisfying the criteria. So that's why I have is alpha here, because upper is only for the strings. Okay, that's how we can use the, you can say, the is instance method. The fourth one is df.add. What does df.add do? This method is used if we want a particular value from the data frame. For example, if I want just 32 or just Selma, that's what this method will help us to do. Here I created this, I have this data frame here. Suppose I want to access this Cameroon Diaz. So what it will do, it will do like df.add, what's the first row, what's the row index, second, and then what's the column name, column name is name. Here if I do this, it will just return me the Cameroon Diaz. So you can say it's an alternate of lock if we want just one value. So we cannot get multiple values with the help of df.add. We can just get only single value using df.add. So suppose in df dot add, I want to modify some particular value. Here this is 25. So how can I get it? df dot add fourth and then age. Let me see this. Yeah, this is like this. And here I want to modify it. How can I modify it? Just for this I will put like, I want it like how much? 26. It modified to it, and if I run it here df again, now here instead of this 25 it is 26. That's how we can use the df dot add on the data frames to access the only single value. Next is df dot apply. What does it do? This is used to apply the function along axis of the particular data frame. We can either apply it on the rows or on the columns. For example, here again, instead of this, let me run this df here. I have this data frame. Give me a second. And on this data frame, I want to, you can say, have one more column based on this age, and I want to see if the age is less than 25, then multiply it with what, 0.9 or something. Yeah, something like that. So for that, what I can do is df of, I will do like modified underscore age is equal to df of age. I want to apply on this. What I want to apply? I want to apply a particular function name. Function underscore name. So for that I have to create a function. So let me create what? Def age underscore modify, and on this I want x. Here if x is less than, suppose let's do 30, return x, I want it multiply by 0.9, else I want to return x 1.1. Okay, this is my function, and here I am passing this function here, age modify, and let us return df. So yeah, so this is the modified age here after applying this particular function. What is this function doing? If the age is less than 30, then multiply it with 0.9. So this is less than 30, multiplied with 0.9, 22.5. This is more than 30. If it's more than 30, then multiply it with 1.1. 35 into 1.1, 38.5. That's how we can apply the, you can say, use the apply on the data frame. So suppose I have a, let me create one more data frame here. Yes, suppose this is the data frame here, and I want to apply the apply function on different axes. Def sum underscore row of x, I will do like return x dot sum. So this is my function that I want to apply, and what I can do is like result underscore rows is equal to, I want to apply on this, and df dot apply, what is my function name? Sum underscore row, and I want to apply on which axis? Is equal to rows. I want to apply it on the row axis, and let me get result underscore rows here. So what is this doing? Let me see the data frame also here first. So here it's doing like 5, 4, 9, 12, 14, 15. So it's summing up all these. So it's summing the values for the rows, and here it's for column 2 it's 150 because it's summing up all these values for the rows. And suppose I want to do the same thing, but here I want to multiply the column. what I want to do, x dot product, and here I will do axis is equal to 1, and what is my function name? Function name is multiply call. This is the data frame. Let me run this. Result calls, and here I will do the result calls. Let me run this. So 10 into 1, it's multiplying this. 10 into 1, 10. 20 into 2, 40. 30 into 3, 90. So that's what this is doing. So we can apply the apply function on both the axes, both horizontally and vertically. Okay, so the next function is apply map function. What does this function do? This function is used to apply whatever function we are going to use on each element of the data frame. Suppose this is the data frame here, and I want to double all the values. So I will do def multiply by 2. This is my function, and I will do return x asterisk 2, and I want to apply on the df dot apply map. What is my function? Multiply by 2 df underscore multiply is equal to this, and I want to see df multiply. So yeah, so this function now is going for all the elements. So now we can see all the elements are doubled. So that's how we can apply the apply map function on the data frames. And there can be multiple use case scenarios, like if you want to check if all the elements are string or not, and if for all the elements if you want to differentiate them, or you can say distinguish them, like odd, even, young, adult, teenagers, something like that. So that's where we can use the apply map function on the data frames. The next function is the iterrows function. What does this function do? This function allows us to iterate over the rows of the data frame as a index and a series pair. What I mean by this, let me fetch this thing here first. Where is my, here I created this data frame, and on this data frame let's first use the simple, like I want to do like for index comma, let's do row in df dot iterrows, just print me the index, print me the row, and then I want a gap in between them. So here it's showing me like for 0th index, name is Megan, age is 25, movie is Transformers. For first index, name is Selma, age is 30, and movie is Desperado. So that's how we can run it. We can use the iterrows over the, you can say, a data frame. And now I am saying it used to give us the index and series. How I know if these are the series? So for example, for this data frame, this is going to be this is the output I am getting, right? Megan 25 Transformers, yes. And I want to say if it's in series or not. So this is at the 0th index. Okay, what I can do, df dot log of this is 0. Yeah, so let me run this. Here this is Megan 25 and Transformers. Okay, let me do the type of this. So here we can see that this is panda score series. So yeah, this is series type. So that's how we can know whatever we are getting, these are the series for each index they are referring to. So now suppose on the same, again I want to perform some operation. Like now I want to half the age here. What I can do? I can do like for index comma row in df dot iterrows, and I want if row, so this row is the series. For this series I want to get the age. Is I want some condition or not? I want to half if they are more than 30. Okay, if row of age is greater than equal to 30, I want for them df. Now here I will use the add function, df dot add for what? For that particular index that age is, and for that what value? The age value. I want is equal to what I want here. I want it as old. Else what? df dot add index and age. I want that as young. Okay, now let me get the df here. Now it changed the values for those particular age based on the criteria that I passed here. So I did like if they are greater than equal to 30, then they are old, otherwise they are young. So like this is old. Oh, what? Yes, these are old and the Megan Fox is still young. That's how we can use the iterrows to change the values or something like that. And again we can apply our, you can say, custom made function that we are going to use. We can apply that function also using the iterrows. So now what's the other thing I have here? Next is itertuples. It's also like iterrows, but it used to iterate over the rows of DataFrame as the, you can say, name tuples. For example, if I have the same here, not this one, if I have the DataFrame, this DataFrame, if I have this DataFrame on this, let's first run it normally to see how it works. What I can do, like for row in df dot iter tuples, just print me the row. Let's see how it works first. Here it's giving me for index 0 name is this, age is this, movie is this. For index 1 name is this, Selma is this. So it's giving me this is full tuple here including the index. And suppose I want to access the just the name here. What I can do, for row in df dot iter tuples, I want to print f of row index is what? What is the row index? Row index is row dot, what is the name here? Index. Row index is this, and name is, what is the name here? For each row I want to access the name. Let's print it. Yeah, so here now we can get it like row index is this and name is this. So this is the way to access the values. What we are iterating? We are iterating row, and what we want to fetch for those, we want to fetch the name. So that's how we can fetch them, something like this. So that's how the iter tuple works over the data frame. Last is like moving multiple data frames. So suppose I have this data frame df, let me get it here, and I have this data frame as df2. Let me get one more only, just one more. I have this data frame and this is df3. I have these three data frames and I did some operations. They are really huge, and like similar to these three, I have like 5-6 more. Like I have 10-15 different data frames. I want to move them to my local machine to do something. So how can I do that? First, what I can do, like I can create a dictionary to map those data frames with the names that I want, and then I can run the loop and then I can move them. What I can do, like I can do like data frames is equal to first file. What is the first? Movies. This is the first file name that I want, and this file name is for what? Data frame. This is for data frame 1. Second one is random 1. This is for df2, and third one is random 3, and this one is for df3. So these are going to be my, you can say, dictionary that I am going to loop over, and then it will save my these data frames in the local machine. So what I can do is like for first is the name that I want, and then df in data frames dot items, file name I want, what I want the file name I want name from this dot csv. This is the file name that I want, and then what I want here, I want like df dot to csv, df to what I want file name, and then I want index is equal to false, and then I will just print all data frames are successfully saved on local machine, something like that. So after running this, so here on my local I don't have any of these files like movies, random 1 and random 3. So let me run this here. After running this, it is printing it out 3 times because it's inside the loop. So here now we can see that I have random 1, movies, and random 3 in my local machine. So that's how we can move different multiple files from the Python to our local, and the same way we can move it from here to our S3 or wherever we are working on them. So these are some of the methods that I want to share in this video that we can use, and we are going to use a lot when we are working with the data frames. I guess in the next video I will cover more about lambda functions, because I guess somewhere here I use lambda function. So I will keep this video until here, and in the next video I will discuss about the lambda functions and how we are going to use them for data frames. I hope this video was helpful. I will see you everyone in the next video. Until then, take care, have a good day, bye.